Hello, good day. Here in this virtual class, we'll be looking at this question before us. We'll have if y is equal to s, the square root of 2x plus 3, show that the y ds is equal to s squared minus s squared over y plus y over x. So the first thing to do here is to look at the question here by dividing both sides by x. We need to manage the x here and as well as the square root, so that the expression here become y over x is equal to the square root of 2x plus 3. And here we need to also look at the square root on the right hand side. In that case, we need to square both sides. So for us to be able to arrive at this, the y dx is equal to s squared over y plus y over x, we must also handle the square root, and by so doing, by squaring both sides, and if that is done, this become y squared over s squared is equal to 2x plus 3. Then this expression here can also be written as y squared times x raised to power minus 2 is equal to 2x plus 3. So you see this, the expression, the left hand side here, we have y and x which act as a product, but normally 6y and x are a product here. That means we'll use product rule as well as the implicit method for finding the derivative of a function. Okay, we use the implicit as well as the product rule. Here, let's now put this into expression. In implicit differentiation, once you are differentiating with respect to y, usually you multiply with the y ds. So here, let's look at this. If we are differentiating y squared, or we multiply with x raised to power minus 2, this s raised to power minus 2, times the y, okay, of what y squared, we'll close the bracket. Remember, since I'm multiplying with respect to y, we usually multiply with the y yes. Please don't forget that from implicit differentiation. Now, let's differentiate x here. Differentiating x. Once you differentiate x, you multiply with y squared. So this will become y squared times the x of x raised to power minus 2. So let's first of all show the expression. This is a product rule. We multiply, you pick one and differentiate the other one. So you pick y here, you pick y, differentiate y, and multiply with x raised to power minus 2. Now you are differentiating with respect to x here, multiplied by y squared. Set on the right hand side, which is 2x plus 3. Here, differentiate with respect to s here. This becomes 2 into 2 times the ds of x plus here 3 the x of 1 here. Okay. So here, let's now arrange appropriately. So here, if we differentiate y squared here, simply saying that from if y is equal to s raised to power n, so your y, if differentiating with respect to y, it means n times s raised to power n minus 1. So if that is applied to this become 2y. So here we have 2y s raised to power minus 2. Remember, we have the y, the x there. Then differentiating s raised to power minus 2, that this gives minus 2 s raised to power minus 3, okay, y squared. Then if we differentiate the right hand side here, which is 2 the x of x, that just gives 1 times 2 is 2 here. The derivative of a constant is 0. So we are seeing something here. We have a 2 as a coefficient, 2r. So usually you divide 2 by 2, divide 2 by 2, Okay, so that the whole expression here become y. It become y. Now recall that x raised to power minus 2 can also be written again as s raised to power y over s raised to power 2. So we can change this from negative indices. So here remember you have the y with respect to the x minus. Here this can also be written as y squared divide s raised to power 3 is equals to 1. Remember, we are looking for the y ds. All we need to do here is to write this is y over s squared, or the y over the x. Now let's quickly move y squared minus y squared over s raised to power 3 to the right hand side. This becomes 1 plus y squared over x raised to the power 3. So we are looking for the y dx. We're looking for the y dx here. That means we need to get rid of y over s squared, and this can easily be done by just simply multiplying through by the reciprocal. So inverse of y over s squared, which is s squared over y. Okay, we multiply through by that. So the expression here, the expression here become s squared over y times y over s squared, the y over the x is equal to, we use this term to also multiply 1, and that gives s squared over y plus, here we have s squared over y times what we have here times y squared over s raised to power 3. So we can see here, this is off. What is left here is the y over the x on the left hand side is equal to, here we also have s squared over y. Okay, s squared over y. But here we have y here reduced by 1y. Okay, so we have s squared here, divide s cubed. What is left here is x. So here become plus y over x. And you see that it has the same expression as what we're asked to show. Please, this is how this expression can be easily be resolved. Well, please, if you like my video, please help me share this on the social media platform. Also, subscribe to my YouTube channel. See you in my next virtual class.